Hi guys, so we have an O-level past paper question from the year 2015. The session is May-June. This is question number 8. This question is based on distance, bearings and loci. So let's get into it. The question says two ports A and B are 15 kilometers apart and B is due south of A. A boat sails from A on a bearing of 141 degrees and then they've given us this drawing right here. State the bearing of A from the boat. That means if this is the boat, if you draw a north over here, just like this, the bearing that they're asking for is this over here. So if I extend this line, the north line, this angle right here would be 180 degrees. If this is 180 degrees, that means this angle right here would be 141 degrees as it's the opposite of this angle. So what you do is you add 180 and 141. Let's see what we get. We add 180 and 141 and we end up at 321 degrees. So we write our answer over here, 321 degrees. The next part says calculate the shortest distance between the boat and B. That means we have to calculate the shortest distance on this line and point B. That means it is always going to be the perpendicular distance. So I draw a line and assume this to be making 90 degrees with the line AX. Let's call this AX or whatever. Okay, so when we have this and we have this as 15, let's find this angle. How do we find this angle? We subtract 180 and 141. When we do 141 minus 180, we get 39 degrees. Since this line is the opposite and we're trying to find the opposite, we will use the sine rule. So sine 39 degrees would be equal to Bx, let's call this x over here, over 15. So Bx would be equal to, I hope this is visible, Bx would be equal to 15 times sine 39. Let's see what value we get. Bx is, let's see, 15 times sine 39. This gives us 9.43. So this is 9.43 kilometers. We write our answer over here, 9.43. Okay, let's move on. The next part says when the boat is due east of B, calculate its distance from A. So if you look at this drawing right here, it is saying that if it's due east of B, that means if you draw a straight line from B connecting to the journey or the path of this boat, it is going to be like this. They're asking us to find this distance, this entire distance from A to this point. Let's call this point Y, and this is going to be 90 degrees. Since we have this angle right here, this is 39 degrees, and we have a 90 degree angle right here, and we have to find this distance AY. So what we do is we do the opposite, we do the adjacent over the hypotenuse. So when we do adjacent over hypotenuse, we use cos 39, and the hypotenuse is what we are trying to look for, and the adjacent is 15. So 15 over AY. So AY would be equal to 15 divided by cos 39. Let's see what we get. 15 divided by cos 39. This gives us 19.3 kilometers. So we write our answer over here. It is 19.3 kilometers. Okay, let's move on. The next part of the question says the scale drawing drawn to a scale of 1 centimeter to 2 kilometers shows A, B and a third point C. This is the drawing that they're talking about. This is A, this is B. Part 1 says when the boat has traveled 24 kilometers, when the boat has traveled 21 kilometers, it stops at point X. Mark and label X on the diagram. So it means that this boat is traveling 24 kilometers, which when converted to centimeters according to the scale would give us, since the scale is 1:2 right here, 24 would be divided by 2. This gives us 12 centimeters. So the boat is at a distance of 12 centimeters from this point right here, and the angle at which it is away from A is 141 degrees. So if we put the protractor over here and we measure angle 141 degrees, it is going to be roughly around here. That means you have to stretch a straight line that is 12 centimeters from this point. 1 second. Okay, so it is going to be 12 centimeters from this point. So we start at A and we have to go in this direction. 12 centimeters is going to be right over here. I hope this is visible. This point is, let's call this point X, and this is 12 centimeters. So let me remove this. Maybe this is used later on. Okay. The next point says mark label X. The next point says a second boat is located less than 12 kilometers from A, nearer to BC than to BA. So since another boat is located that is less than 12 kilometers from A, 12 kilometers in this map would actually mean 12 divided by 2, which is 6 centimeters. So what we do is it is within 6 centimeters from this point over here, right? So the first thing that we need to do is we need to draw an arc that is 6 centimeters wide from A. So we take our compass and we open up to 6 centimeters and then we draw an arc over here. Let's make it simple. Let's make it very simple. It is going to be like this. Okay, so once this is done, it says nearer to BC than to BA. Now, in order to find the distance between BC and BA, I mean the region of the boat, what happens is, first of all, we need to connect BC and AC with straight lines. I hope this is visible. So you connect this and then we connect this point as well. 1 second. Okay, so it said it's nearer to BC than it is to AC or any other point or even AB. So what we need to do is we need to construct an angle bisector at B so that we can enclose this region by a straight line, and the angle that is towards BC would be the region. How do we do that? First of all, in order to construct the angle bisector, we open our compass up to this point, maybe like this, and then maybe like this. And then what we do is we put our compass over here, draw a line like this, and then put our compass over here, draw another line like this. And then since we have this arc right here, I hope this is visible, we construct a straight line that goes through B and this point, which is like this. So nearer to BC, right, and then less than 12 kilometers from A. This means that the region enclosed by this semicircle right here, this whole region. So this is what I was talking about. This is the line that this is the region that has been shaded, that is nearer to BC than to BA. The last point of the question says the point Y is the position of the second boat when it is as far as possible from X. Mark and label Y on the diagram and hence find the maximum possible distance between the two boats. Now, in order to find the maximum possible distance, we need to look at X first. I hope X is visible. And the maximum possible distance can either be this point right here, or it can either be this point, if this is visible, right here. So actually the maximum possible distance is this point. So let's measure this point. This is like 9.2 centimeters. So that means if this is 9.2 centimeters and you're trying to look for the distance, it is going to be 9.2 times 2, since you're converting this into kilometers, and this comes out to be 18.4. Then you write it over here, 18.4 kilometers, and we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.